So what we're going to do now as a next part, we're going to do a little bit more graphing, but I promise this will not be bad at all. What we're going to do is we're going to graph and come up with a figure. And we're going to determine what kind of figure that is based on our knowledge of figures we have talked about before. There is going to be something new that I haven't really went over here, but you're going to be remembering the figures that I just talked about. And after you graph it, we're going to determine the name of this figure or even what type of figure this would be. So first, I'm going to have you graph the 4 points on your graph paper or in your notebook. And if you did that, hopefully your figure looks something like this. And maybe you can start guessing already, but we're going to answer the 2 questions. Looking at the slopes, how do the slopes tell you that this is a parallelogram? What do the slopes tell you about the shape being a rectangle? So in order to be able to answer these questions and determine whether this is parallelogram or rectangle, we need to find the slope of each of those lines. So let's do that. I'm going to zoom in here to the graph. You can write it on the graph or you can write it in the box if you have the handout. Let's start with line AB. Line AB looks like it's going to be from A to B going up to right 3. So the slope I got 2/3. This one I'm going to be going from point C. Going to go 1, 2, 3, 4, 5. Up 5. And then left 2. So -2. CD. I'm going to go down 2. And then left 3, which is -3, but negative over negative makes it a positive. So I can say the slope is positive 2/3. I'm going to go from A to D. So 1, 2, 3, 4, 5. This is down 5 and then right 2. -5/2. So what do you notice? These 2 sides have the same slope. These 2 are parallel. Same slope, parallel lines. These 2 sides, one's negative, one's up. These are both negative. This can be written as -5/2. This can also be -5/2. They also have the same slope. So these 2 sides are also parallel. Hopefully you have that in your figure. So then going back to the top, I'm going to put all these slopes together. AB was 2/3. BC was -5/2. CD 2/3, -5/2. So looking at the slopes, how do you know that this is a parallelogram? Parallelogram is when opposite sides are parallel and congruent. We're actually not going to find the length. We're not going to find the length, but we're just going to see if they are parallel. In this case, yes, opposite sides are parallel. So we know that this is a parallelogram. And how do we know that the opposite sides are parallel? Because they have the same slope. All right, so here's the answer. Opposite sides have the same slope, so they are parallel. And therefore, this is a parallelogram. Now the next part. How can we tell from looking at the slope that this is now a rectangle? Rectangles, they also have opposite sides parallel. They do also have opposite sides the same. But what else they have? They have 90-degree angles everywhere. And how do we determine whether lines have 90-degree angles or not? That's when these 2 lines are perpendicular. The sides next to each other have to be perpendicular, right? They have to have opposite reciprocal slopes. That creates the right angle. So then looking at my figures, are these 2 sides, the adjacent sides next to each other, are they perpendicular? Are these perpendicular? Do they create 90-degree angle? Are these perpendicular? we can't assume by the picture. So then we look at the slope. Are these two slopes opposite reciprocals? And if it's hard to see, look at from here. Are these two slopes opposite reciprocals? Are these opposite reciprocals? The answer's no. They are opposites, but they're not reciprocals of each other. Therefore, the sides that are next to each other are not perpendicular, meaning they don't have right angles. So here's what we can say. It's not a rectangle because there aren't any perpendicular lines that make right angles. And how do we know that? Because the sides that are next to each other are not perpendicular and they do not have opposite reciprocal slopes. They don't have opposite reciprocals. Okay? So that's how we're going to determine figures using information we know about slope. And we're going to practice one more this time with a different one. So I'm going to have you try it again. Graph the 4 points. Make sure you label MATH. And you can continue on your own to figure out what kind of figure this is by finding the slope and actually the side length if you can. Otherwise, come back to the video and we'll go through this together. So here's a figure. Hopefully yours look like mine. Now we're going to find the slope of each of those two sides. And also this time we're going to do one additional part length of each side. So let's start with MA. Actually, no, let's start with MH or HM. This is a vertical line, right? What's the slope of a vertical line? Straight down, it's undefined, right? Slope of this vertical line is undefined. This is also a vertical line, so AT is also undefined, easy. And what I'm going to do is I'm also going to find the length because I can just count boxes. 1, 2, 3, 4, 5. So AT has a length of 5. And MH, 1, 2, 3, 4, 5, also has a length of 5. I'm done with 2 of the sides already. And now for the other ones, side MA and TH, I'm actually going to create those slope triangles again to find the slope. So let's start with MA. The slope of this line, it looks like it's going to go up 3. And then 1, 2, 3, 4, left 4. So I got the slope of line MA to be -3/4, right? Goes up 3 and left 4. Left is negative. And then TH or HT, whatever you call it, it looks like it's going to go down 3 and then 1, 2, 3, 4, right 4. So this is also -3/4. Now we know that these two opposite sides of the parallel lines, right? See the side lengths. To find side length, just like we did in the beginning, we're going to use Pythagorean theorem. So let's use these triangles that we created. This triangle, this side length is a 4. This is a 3. That's how we found it using slope triangles. So then we need to find the side length MA, which is the hypotenuse of the triangle. So 3 squared plus 4 squared should equal to x squared. 9 plus 16, which is equal to 25. So the hypotenuse is square root of 25, which we know simplifies to just 5, right? So the side MA is also 5 units long. And if you actually look at TH, it had the same slope triangle, has the height of 3 and the base was 4. So this one, without even doing the Pythagorean theorem, we already know that this should also be equal to 3 squared plus 4 squared is equal to x squared. And it's going to be square root of 25 for the hypotenuse, which is the same. Because these are the exact same slope triangles. So this is going to be also 5 units long. So we found all the slope of the lines, find the length. Let's see if we can determine the bottoms. First of all, is this figure a parallelogram? Meaning, are the opposite sides parallel? The answer is going to be yes. Opposite sides are parallel because the opposite sides have the same slope. Now, next part, is this a rectangle? What is a rectangle? Rectangle is when opposite sides are parallel and opposite sides are the same, but also we need to have 90-degree angles. We need to see if the sides that are next to each other are perpendicular or not. Okay. Well, the sides that are next to each other, do they have opposite reciprocal slopes? No, they're not opposite reciprocals. Not opposite reciprocals. Not opposite reciprocals. Therefore, there aren't any perpendicular lines, meaning these two are not perpendicular. These two are not perpendicular. There aren't any right angles. So this is actually not a rectangle. So I'm going to say no, because there are no perpendicular lines that make 90-degree angles. And how do we know that? We know that because none of them have opposite reciprocal slopes. Okay, none of them have opposite reciprocal slopes. So then the last part, this is something new, rhombus. First of all, what is a rhombus? Rhombus is the one that has like the diamond shape generally. And what's special about them is that all four sides are congruent and opposite sides are parallel. Okay, opposite sides are parallel. And also, they tend to have opposite angles congruent. Okay, but that's all we need to know about rhombus. All four sides the same, opposite sides parallel. They do not necessarily have 90-degree angles. They don't necessarily have 90-degree angles. So then coming back to our figure, are all four sides the same? Yes. Are opposite sides parallel? Yes. Therefore, this is a rhombus. Yes, rhombus, because opposite sides parallel, meaning they have the same slope, and all four sides have the same length. Okay, and that's it. That's the end of the video. So make sure, again, you know how to find the slope of each of those sides and find the length of each of the sides using Pythagorean theorem. And that was the main for today's lesson.